Hey guys, welcome back. So today is part two of our terrain-based particle system. So what we're looking at now is kind of what we're building up to over the course of the next several tutorials. Uh, we have done the first part already. That was procedurally generating a terrain-based height map. I highly recommend you check out that tutorial first before jumping into this one. You can still get a lot out of this, but we are going to be using that as a core component in the second half of this tutorial. So again, if you haven't went through and followed along to create that, I recommend you do so now. Um, Alternatively, it's available on my Patreon if you prefer. So now let's take a look at what we're going to do today. And that is going to be this. So today we're going to focus on the particle system aspect of this entire effect. So we're going to take the touch designer component, or sorry, the touch designer palette component particle GPU, tweak a few things, and learn how to make it our own and look something like this. So this will be obviously pretty integral in the overall effect. So it is exciting to be able to go through this today, and I hope everybody enjoys. So here again is what we'll be doing. We'll have procedural noise. That's what we did last time. We will have, this is just a color map, and this is going to be particle positions. We'll pass those into the particle GPU with just a couple parameter tweaks. We'll hit it with some post, and that's going to be our effect. So let's get started. Control B for the palette, particles GPU. And let's look at it. Cool. So yes, particle GPU. Not going to go into everything this guy can do. There's a lot of good tutorials out there from Elbers and others. So recommend you guys check those out for a more thorough introduction to the component. I'm just going to be going through what you got to change to make it look the way that I want it to look. Start, let's head to the material and change that to a line. Then we're going to go to render, change the res, so it's a little bit nicer for us. We're going to go to forces. I'm going to turn off the external magnitude. I'm going to birth 10,000 particles by frame. And that'll be good for now. Now we see all of our particles are being birthed, but not really moving. So we need to tell them where to be birthed so that they are more properly aligned with our field of view. And to do that, we're going to use a UV mapping. If we jump into the particles GPU, we can see that what's going on is this point generator is generating essentially just some noise. That noise is used as a particle source. It's being randomized using this remap, and that is what is being grabbed to initialize points as they are turned into particles and added to our simulation. So what we want is to have a grid of particles. So we're going to use UV locations, which I'm going to create just right here in GLSL. Very simple, small case v, big uv.st, comma 0, comma 1. And there we have a UV mapping. I'm going to put this in the range 0 to 1. Put a null, call it pose, and whoops, not drag, map it. So we can see now that our particles are starting to be birthed in this region, which is starting to look a lot more like the grid that we want it to. You You can also see some interesting motion starting to appear, but we want to get it centered a lot better on the screen, obviously. So to do that, we're going to jump into Particles GPU. I'm going to get rid of this camera and replace it with one of my own. So first, I'm going to change the name. I'm going to create a new camera. I'm going to point this camera at my render. Call it camera, and then delete this. Then just need to zoom in. And now we can just position our particles within our field of view. Now we need a lot more particles and they need to be a lot smaller. So I'm going to make the size smaller. And we're going to add some feedback so that we can see what we're looking at. So feedback into composite it right with the particles GPU and an over. Drop that, and then we start to see some interesting things appear. Now, at this stage, I'm going to drop all this down to a component, call that particles watershed, and that will allow us to start parameterizing some of this as we're working, which will help keep things efficient. So first, we definitely want to grab the resolution. Okay, so we're trying to remap from -1 to 1 and have this show up centered in our screen, but it's not, and it's not because we need to set the pixel format to 32-bit float. I'm going to keep customizing the component, going to drop the reset onto here. I'm going to open the parameters, take that reset, drop it onto my feedback. Now I have a global op shortcut that I have this pulse on that is available in a startup file on my Patreon for those that are interested. But for right now, I'm just going to use that to trigger a reset. I have it mapped to 1, which you can see how to do in my keyboard shortcut tutorial. And so every time I hit 1, it's just going to reset both our particle system and our feedback. Let's take a look. Very good. We want to add the ability for us to add some decay. Set the opacity. There you go. We'll throw a transform down to add some background color. Will give us the ability to turn that on and off. Put a null here. Clean this up by collapsing these components. And you know what? That can actually go in here too. I would love if derivative could find a way to automatically update references when you change hierarchy. It would be sick. Okay, so now we're centered. We can maybe just give ourselves the camera position as a parameter so that we can control it easily from here. Things are looking good. All right, so you notice that it's probably kind of pulsing, right? So there's these particles, they all get birthed at the same time. They all generally die at the same time, and then there's like a reset like this. Could be desirable for some cases, but not for me. So I'm going to change my life to 10 and variance to 5 and reset. And that should result in a much more consistent creation of particles. So you can customize that for sure. I generally find that life with a variance of half of it is pretty good for getting pretty close, which makes sense if it's a random distribution. So now we want to make this aspect correct so that our particles can fill the entire screen without distortion. So to do that, we're going to use a couple math tops. We're going to take the range, and to do this, maybe I'll go as okay, sorry about that. Someone at my door. So yes, we lost our particle system when we changed the resolution, and we need to aspect correct its location to get it back, which, like I said, some math tops. All right, so our range for x is going to be -1 to 1, and our range for y is going to be the aspect ratio, which is parent dot par dot resolution h over parent dot par dot resolution w. And then I will just drag that, make it not negative, and let's pipe this in instead. And nice. Now we can see that there are indeed aspect corrected positions happening. And let's see what happens if we go to 1920 by 1080. It also seems like it's working. And we can play with our camera position as needed to even things out. Cool, so we don't need this anymore. And turn these off because we're done with those. Let's add some color, which I'll just do with the noise, just to make it very easy. And then for a bit of definition. And then finally, always best practice. Cool. So we give it some color. All right, and now we're starting to look pretty good. I think we might want, yeah, okay. So you want to make sure that we're doing the feedback over the actual output. Sorry about that. All right, so now things are looking pretty good. All right, so now I think it's time for us to add some procedural terrain. And to do that, I want it to be just a little bit more dense. I'm going to add a particles page to my parameters. I'm going to drop in some parameters. You're going to want to make sure you take off this enable expression when you drop in, otherwise you get some errors. They don't actually do anything, but I find them annoying. Life and life variance are good. Size, we'll check out later. Size is pretty fun. Again, just taking off those enable expressions. Otherwise, you will get some angry messages. We can add our turbulence magnitude. Our turbulence magnitude right now is the only force acting on this. So if we turn this down, everything comes to a halt because right now turbulence is the only thing at play. And we can make it go fast with a 2. So we'll parameterize that. We've already got our resolution, and I don't think we need anything else for the moment. You'll also want to turn off display bounds. You saw them earlier. The blue lines, you want to get rid of those. Cool. So you're definitely welcome and encouraged to play around with the rest of the behavior here. All these parameters, there's truly just so much to explore. It's deserving of a series in and of itself, maybe someday. So now I want to add terrain to this. And here's where I'm going to drop in my procedural terrain top. I'm going to set this output to 512 by 512. Let's take a look. And let's grab the gradient. So before we add this, actually, let's take a look at what happens when we just use a regular noise. We can just use this one, actually, that everyone knows for a effector. So I'm going to put it in the optical flow output. Disconnect that. You could put it in the particle velocity output, but I personally think that the optical flow gives you a little bit more control. So I generally use that input. Now, things are getting a bit crazy. I'm going to give us some help here. So I'm going to insert a GLSL. Don't worry, it's not going to be too intense. Edit. Bring this down. Make it bigger. And zoom. All right, hopefully you can see that. All right, so what I'm going to do here is add a vector called uWeight. I'm going to add a parameter called velocity gain. It's just going to be a float, and it can just go from 0 to 1. We'll map it here. Nope. Do it the easy way. There we go. And then back to our code. So we wait, or I guess for good convention, I should probably be calling this gain. So my color will be my input, and I'm going to, since we're just taking the XY channels for velocity, just normalize those two channels, and then, normalize those two channels, and then multiply it by my gain parameter. And actually, because I know the multiples are going to be very large, I'm going to divide this by 250 as well. And then just make a note, divide by 250 simply to allow more user friendly input range, because we need very small values to go into our particle. So we want to make sure that I don't like using the parameters that go from like 0 to 0.001. So this will allow us to go from 0 to 1 on gain. But actually, only adding a very small amount of the velocity. So maybe somewhere around there. And I'm just going to set this to 32-bit float RG. Cool. And then I'm going to turn off the turbulence so that we can just see what's happening with our noise. Maybe turn up the amplitude, turn down the offset, turn monochrome. Oops. There we go. Down the offset, turn up the amplitude. Maybe turn down the period a bit and give it a bit more interest. Nice. So we can see that there are responsive changes happening now in our particle system, and we can get some pretty fine control using the velocity map as an input. And that is going to be kind of the foundation for a lot of the rest of the stuff that we'll be doing, frankly, in this and a lot of other tutorials, most likely, because it's a pretty powerful technique to define a system like this controlled from velocity maps and then carefully craft those velocity maps using whatever design you like to have very fine control and can lead to some very cool, smooth transitions and I think pretty compelling effects. So now that we've seen what can happen, and for goodness, let's just plug this into. Let's see what that looks like. Now we can see it's more like a wavy. It's more like a wavy, interesting shape. So now what we're going to do is plug in our gradient right into that GLSL and reset and take a look. And so now we are certainly getting there. So we can see that if we just don't translate this, get rid of these for a moment, we can see that our terrain has these ridge lines and gradients and smaller patterns that we can see reflected here when the noise is paused. So I think that's pretty awesome. So I'm going to translate the noise to get a little bit of motion, but I'm going to do it very slowly. So I'm going to say abs time dot seconds times 0.01 actually. So it moves really slowly. And that's going to give us these really nice curls, interesting pattern formation that is reminiscent of the mountain ranges. One thing that I think can help kind of punctuate is if the color is mapped to the velocity field so that there's cuts in color at the same point that there's cuts in velocity. And it's a nice, easy way to make it look a little bit more deep. So to do that, we're going to use a remap. I'm going to take another GLSL and actually do something pretty similar. So maybe I'll just copy and paste this one, grab the pixel shader, and we are actually just going to take this part out. So we're going to normalize this back now to 0 and 1, which is just this same gradient, just normalized to 0 to 1. So we can say normalize 0, 1, and this is normalize and apply gain. Cool. So this we're going to put into the remap, and it needs to be this way. No, it needs to be this way. I'll wire this in. Extend to repeat or mirror. I'm going to do repeat, I think. I'm going to use this because it's a bit of a better color. Less noise for what I'm trying to show. And then to reduce a bit of clutter, we can throw a blur in here. And so what I'm trying to do here basically is just take our input color and just remap it using the same contours that our velocity field is going to be creating with the particles, because I think it maps the trajectories pretty nicely and provides some depth and just cool highlights. But it's pretty stylistic, so you can, either do that or not. And yeah, obviously, like the blur and everything is optional. Yeah, so now we have a procedural terrain piped into this particle GPU that we tweaked to suit our purposes. We have a nicely customized component. Maybe we want to add to that customized component a few things, like maybe the period for our noise, probably not much else. We already have weight. Yeah, so I guess we can probably just clean this up a little bit. We can say this is particle location. Use a select to clean some of this up. Let me just get rid of this noise for now. I don't think we really need that. We will make this an input and call it color in. We will also make this an input and call it velocity in. We don't actually need this. Cool, so that's all looking good. We can get this back here. Oops. Color mapping. And here we will say velocity map. Organize all of this. Call this feedback and post. Boom. Now we have a nicely organized, quite responsive component that will allow us to really go from here and have a nice framework within which to build out the rest of our effect. Add some complexity. We will be adding some fluid simulation effects. We'll be adding an optical flow and a number of other things to fine tune this, and also offer a couple ways for you guys to just explore, because there's definitely some ideas I've had that I haven't had the time to explore myself. So maybe it'll inspire something. So with that, I appreciate everyone's support, especially my new patrons. It really means a lot and enables me to do this a lot more than I would otherwise. So truly appreciate it so much. And I'll see you guys next time.